question is from GATE 2019, Mechanical Engineering paper, Set 1. It's question number 46. A cube of side 100 mm is placed at the bottom of an empty container on one of its faces. The density of the material of the cube is 800 kg per meter cube. Liquid of density 1000 kg per meter cube is now poured into the container. The minimum height to which the liquid needs to be poured into the container for the cube to just lift up is dash mm. Here we need to find out if in an empty container there is a cube placed with this density and we are pouring in liquid. We have to find out how much of the height of liquid we need to pour for the cube to just lift. Let me represent the given information into a figure. So this is the container which is empty right now and a cube is being placed inside the container with the density 800 kg per meter cube. Now liquid is being poured inside the container. Let the height of the liquid be h when the cube just lifts from the base of the container. There is liquid under the cube which is showing that when we have h height of the liquid inside the container, the cube has just lifted. Now we know that the cube will just lift only when the liquid will be able to generate enough buoyant force. That buoyant force will be equal to weight of the cube. So as soon as the buoyant force generated by the liquid on the cube is equal to its weight, the cube will just lift. I will also show it by a free body diagram. So here we can see on the cube there's this buoyant force which is coming from the liquid and the weight of the cube which acts downwards. Finding individually both the forces and then equating them, we can find the height h. After learning about this concept, if you want to try solving it yourself, you can pause the video and try finding the value of h. Now force of buoyancy on the container by using hydrostatic law is equal to density of the liquid into g into submerged volume of cube. Let this symbol represent the submerged volume of cube, which is equal to density of the liquid is given to be 1000 kg per meter cube. Keep g as it is. Submerged volume of the cube is nothing but its base area, this base area, into the height h. So we can write base area is nothing but 100 mm square into h. So is this the force of buoyancy? Let's find the weight of the cube. Weight of the cube will be equal to its density into g into its volume. So rho of cube into g into volume of cube, which is equal to 800 is the density, 800 kg per meter cube. Keep g as it is and volume of cube will be 100 mm cube of it. Let's now equate force of buoyancy and weight to find out the unknown h. We have 1000 g h into 100 square is equal to 800 g into 100 cube. To be noted here, this area is nothing but base area of the cube because we are finding out the force of buoyancy on the cube. We will not take the base area of the cylinder, we will take the base area of the cube. Hence, keeping h on one side, we get 800 into 100 cube upon 1000 into 100 square. It's equal to 0 getting cancelled 0.8 into 100, that is nothing but 80, and the unit we did not change for the dimensions of cube, so the unit that we are getting is mm. Density upon density, it's unitless, into this is volume in mm cube, this is area in mm square, so we get the height value in mm. We can write the answer here as 80, unit is already given mm. To learn the concept of buoyancy for fully or partially submerged bodies, you can refer to the NPTEL video module 7, lecture 7, Fluid Statics part 4, Fluid Mechanics by Professor S.K. Som, Department of Mechanical Engineering, IIT Kharagpur. I hope you understood this solution. Thank you.